Beyond the basics, advanced MCP architectures for controlling your entire app ecosystem. If you've followed the shorts on Claude and MCP, you already know the fundamentals. Today we go deeper into the architectures people are actually experimenting with to orchestrate entire fleets of tools and agents. Quick recap. MCP, the Model Context Protocol, standardizes how large language models connect to external tools, data, and APIs. Instead of hand-rolling a custom integration for every service, you expose it once as an MCP server, and any MCP-compatible client, like Claude, can discover and call it. That's the basic pattern: one client, one server, structured tool calls. Beyond the basics starts when you have more than one server and more than one agent. Architecture 1. Multi-server orchestration. Instead of a single MCP server exposing every tool, you run several specialized servers, one for your database, one for your file system, one for your internal APIs, one for search. A single client connects to all of them simultaneously, discovering their combined tool sets and routing each call to the right server. This is the hub-and-spoke pattern, modular, plug and play, and it scales far better than one monolithic server trying to do everything. Architecture 2. Pairing MCP with A2A, the agent-to-agent protocol introduced by Google. Here's the distinction that matters. MCP governs how an agent connects to tools and data, the resource layer. A2A governs how one agent talks directly to another agent, as a peer, rather than as a tool. In practice, the architecture that's emerging looks like this. MCP handles your external integrations, while A2A, or an orchestration framework sitting above it, handles the routing between agents themselves. Architecture 3. Multi-agent orchestration frameworks. Production systems increasingly decompose work across specialized agents: a planner that decides what to do, a researcher that gathers information, a coder that writes the implementation, and a critic that reviews the output. Frameworks like LangGraph model this as a graph. AutoGen models it as a structured group conversation. CrewAI models it as a crew, with defined roles and tasks. All of them connect to MCP servers as their tool source, meaning the same underlying tool ecosystem, and power very different orchestration styles. Architecture 4. Handoffs and chaining. Instead of one agent doing everything, control passes explicitly from agent to agent as a task progresses. A support agent that hits a billing question hands off to a billing specialist agent, carrying full context forward. A coding agent that finishes implementation hands off to a review agent. These handoffs, combined with dynamic chaining, where the sequence of agents isn't fixed in advance, but decided at runtime, let you build workflows that adapt to what's actually happening, not just what you predicted in advance. The part people underestimate: durability and checkpointing. Long-running agent workflows need to survive process restarts, resume after errors, and handle human-in-the-loop pauses that can span hours or even days. This means snapshotting shared and per-agent state at every step, storing serialized conversation threads keyed by session, and ensuring session isolation so that one user's workflow never leaks into another's. Without this, a 5-agent pipeline that fails on step 4 just loses everything and starts over, which is not something you can ship to production. Architecture 5. Reflection and self-correction. Instead of an agent producing one output and stopping, a reflection pattern has it critique its own work, or route it to a dedicated critic agent, before finalizing. This is especially powerful combined with what's sometimes called magnetic orchestration, a flexible collaboration model where agents aren't locked into a fixed sequence, but dynamically pull each other into the loop based on what the task actually needs at that moment. Why does this matter right now? In 2026, enterprises that have mastered this orchestration layer are reporting real numbers, cutting operational costs by 35 to 40% and accelerating decision cycles by roughly half. And in organizations that are struggling aren't failing because of model quality. They're failing because of governance gaps: no session isolation, no checkpointing, no clear boundary between the tool layer and the agent coordination layer. So here's the practical takeaway. Use MCP for what it's built for: exposing tools, data, and APIs in a structured, discoverable way. Use an orchestration layer, whether that's A2A, LangGraph, AutoGen, or CrewAI, for what it's built for: routing, handoffs, and coordination between agents. Add your abilities so failures don't erase your progress. And add reflection so your agents can catch their own mistakes. That's how you go from a single MCP integration to controlling an entire app ecosystem.